This is the E of Real Estate. My name is Rene Stevens. I'm your host, and my guest today is John Stuart Reid from the UK. John is an independent English sound and acoustics engineer, scientist and co-inventor of the Cymoscope, an instrument that makes the inherent geometries of sound visible, and the Cymoscope app, which reveals cymatic energy patterns in real time from voice or music. He has studied the world of sound for over 40 years and shares his research findings to audiences throughout Europe and the United States. John's work is inspired by the famous acoustic pioneers like Ernst Gladney, Mary D. Waller and Hans Jenny, and has taken their findings to the next level. His primary interests are investigating sound as a formative force and discovering why sound heals. So that is really interesting. So welcome, John.
Thank you for that lovely introduction, Rene. It's a great pleasure to be with you today.
It's my pleasure. Thank you. Einstein once said, "The more you know, the more you realize how much you don't know." Or maybe, in this case, the quote of John Lennon is more appropriate for cymatics. "The more I see, the less I know for sure." Does this apply to you when you look back on your 40 years of research in making the invisible visible and lift some veils that conceal many mysteries of the universe?
Of course it applies to me. It applies to every scientist, I'm sure, that we all recognize that the more that we discover, the more we find there's more to discover. But that's part of the joy, of course, of science, isn't it? You know,
yes.
That we delve in deeper and deeper and learn more and more. And the mysteries of the universe become more and more evident to us as we delve into them. So yes, of course, and that, as I say, that is part of the exciting aspect of science.
Yeah, that keeps us moving in investigating more and more. In this podcast, I would like to explore some building blocks of your research and the findings about effects of sound and frequency, and then connect them, if possible, into a practical application for the built environment, and in specific for university campuses and schools.
Sure.
The Cymoscope, I found that a wonderful quote, so I took that from your website. The Cymoscope, like the invention of the microscope and telescope, opens a realm not previously suspected to exist. A whole new world of visible sound. So maybe for our listeners, you can say in short what is cymatics and what does the Cymoscope instrument and the app do?
Of course. And by the way, here is the Cymoscope instrument right behind me here, this lovely blue device. So in essence, whenever sound meets a membrane of any kind, there has to be an imprint of energy, acoustic energy, on that membrane. And these are just the laws of physics. And one of the wonderful things about cymatics, which is this field of sound made visible, is that scale appears to be completely irrelevant. And I'm going to give you two examples of this in a moment or two. But simply this, that when sound meets a membrane, there will be flexations of that membrane. And the membrane can be anything from the surface of water, which is used in the Cymoscope instrument, to our own skin, or even to a metal plate, which I think many of your listeners will know of the work of Ernst Gladney, who made this whole science of modal phenomena, which is the kind of generic term for it, made it famous throughout Europe, and then, of course, now throughout the world. So yes, in essence, it's simply that whenever sound encounters a membrane, a pattern of energy will be imprinted on the membrane. Of course, the pattern will vary depending upon the qualities of the membrane. But in terms of scale, we go right, in terms of my work, we go right from the microscopic realm, so literally imaging sound on the surface of living cells. And then into the macroscopic world, of course, in the CymaScope instrument. Let me just take out for you the cuvette, just to give you an idea what it is. Here's the little fused quartz cuvette. You can see it has a black bottom, which is made of quartz as well. That is black quartz, black fused quartz. And so here we have something which is about 25 millimeters in diameter. Other CymaScope models use smaller areas of water. Other models use larger areas of water, depending upon the bandwidth of the frequencies that we're interested in studying. But then if you go to the other end of the scale, to the kind of cosmic scale, looking at the planet Saturn, on the north pole of the planet Saturn, some of your listeners will know that there is a giant hexagon. It's so large, Rene, that it could swallow 3 Earths. Oh. and the hexagon pattern, of course, is formed, in my hypothesis at least, by sound. In order to create structure in cymatics, you have to have obviously an initiating sound, an exciting sound. And the sound relates the structure, in this case, the geometric structure of a hexagon. For that to be formed by sound, it would have to be a very, very low frequency sound, of course. And in my hypothesis, that emerges from a geyser or a geyser, however you say it, that emerges from the depths of Saturn, comes up into the atmosphere and forms this giant hexagon. Now, you have to have a boundary condition in any cymatics work, of course. In the case of Saturn, there is a giant storm, a circular storm, and with winds running at, I don't know, thousands of kilometers per hour. So that giant storm forms the kind of outer boundary, you could say, boundary condition for this low frequency sound. In the case of back on Earth here, of course, for a human cell, the boundary condition, of course, is the membrane of the cell. In the cuvette of the CymaScope, the boundary condition, of course, is the fused quartz, in this case, circular fused quartz cuvette. And I know you want to talk about architecture and buildings, of course, and in that case, obviously, the enclosed built space forms the boundary condition. So we can talk about all of that, but it's a wonderful new science of cymatics. The word was coined by Hans Jenny, the Swiss physicist and musician, and it simply means sound made visible, and it is a fabulous new science.
It really is. But it all started in Egypt with you, I understood, when you did your first research over there. So when geometry is the visible form of sound vibration, therefore buildings and their components like materials, colors, shapes, angles, etc. are in a way frozen music, like the German writer Johann Wolfgang von Goethe said, architecture is frozen music.
Yes, that's a lovely quote.
Yes, it is, and especially in this context. So in the 96, I believe, and 97, you carried out some research in the King's Chamber in the Great Pyramid in Egypt, studying the resonant behavior of the granite material of the sarcophagus in relation to its shape, so the King's Chamber. So now, 25 years later, are there new insights about your hypothesis that the development of the hieroglyphic writing could be influenced during crafting of the stone?
Sorry, say that again, please, Rene.
So now we are 25 years later.
Yes.
Are there new insights about your hypothesis that the development of the hieroglyphic writing could be influenced during the crafting of the stone, of the granite stone?
Oh yes, of course. It's a really interesting hypothesis. So what had happened here was that Towards the end of my career in acoustics, this was in the early 90s. I came across the work of this Hans Jenny, who had carried out some really wonderful experiments in cymatics, more from a kind of artistic viewpoint, I would say, than from a scientific viewpoint. He had very keen powers of observation, that's for sure, and he wrote two beautiful books full of gorgeous pictures of dynamic phenomena, you know, in the world of cymatics. And when I came across his work, it certainly inspired me. And my daddy and we had traveled in Egypt many times, but in '96, early in '96, we managed to get into the Great Pyramid alone. We had been in before, but in this case, we were in there alone, which was just, you know, happenstance. It was fortuitous. And I wanted to lie in the sarcophagus, which I think the antiquities department would not really encourage. But anyway, I did. I lay in the sarcophagus and I created a vocal glissando. You know, the King's Chamber, for those of your viewers and listeners who have not experienced it for themselves, it's an extraordinary chamber. It's austere. It has no hieroglyphic writings on it or, you know, any kind of decoration at all. Made of rose granite from Aswan, which is about 600 miles south of Giza, where the pyramids are. And it has an extraordinary acoustic. You know, you can, if you're very quiet, if you just stay still and listen, you can even hear the sound of your own blood, you know, coursing in your ears, and you can, of course, hear your heartbeat and so on. It's like a kind of reverse of an anechoic chamber, you know, it's highly reverberative. So anyway, I lay in the sarcophagus, I made this vocal glissando, and at one particular vocal pitch, I felt every cell in my body tingle, and this kind of wave of acoustic energy washed up and down, you know, my whole body, and goosebumps broke out all over my flesh. And it was an extraordinary moment. You know, having been at that point an acoustics engineer for a ballpark 25 years, I had never experienced anything like that. So it really did get my attention. And what it said to me, Rene, in that moment was that this felt like design. It felt as though somehow the Egyptians had contrived this effect. Why would you make a chamber of granite, specifically of granite, as opposed to any other stone? Why would you go to all that trouble, you know, bringing it from Aswan, 600 miles, you know, to the south? That's a lot of work to extract it from the quarry, to bring it to Egypt and so on. So I realized there had to be, you know, a design here, a design impact. And so the intention was, following that experience, to go back to the King's Chamber armed with acoustics instrumentation. And I know we haven't got a lot of time today, so I'm going to cut this quite short by saying I did indeed go back. I went back in later that same year, '96, carried out a series of very successful acoustics experiments, standard acoustics experiments, and reverberation time, you know, for example, pink noise tests and so on, all the usual kind of tests that an acoustics engineer carries out. The one experiment that I really wanted to conduct, but there was not time because I had been given a very limited window of time by the Antiquities Inspectorate. I wanted to carry out this cymatics experiment with the sarcophagus. So let's just talk a little bit first about the sarcophagus. It's a block of rose granite, again, that's been hollowed out. It weighs approximately 3.7 tons. It's in a specific position in the King's Chamber. And if you strike it with the side of your fist, which again, I'm sure the Antiquities Inspectorate would not wish you to do. But anyway, of course, as an engineer, I was very interested in the resonance of that granite box, especially because Aswan granite contains about 20% of quartz crystal. It's very high quartz content, so it makes it very, very resonant. And so when you strike it with your fist, it rings like a low-pitched bell, and it's quite a rich, harmonically rich sound. It's not just a pure tone, of course. It has many harmonics because of the quartz content. And so it's a fascinating sound. And I thought, wow, wouldn't it be wonderful, having read about the work of Jenny, wouldn't it be wonderful to be able to see those resonances, to actually make them visible? So I obtained permission and went back again, this time in 97. But the thing that's, one of the aspects to the 97 mission, which was so important, turned out to be so important, was an injury to my lower back. So about 3 weeks before traveling out to Egypt, I actually had built a replica of the sarcophagus in wood and timber, in order to rehearse the whole experiment, to be able to, make sure that I could carry out everything I needed to do within the allotted time. And so having built this, I was really exhausted, Rene. I was really, really fatigued. And I think it was the fatigue that led to this injury of my lower back. Consequently, 3 weeks before, I was in severe pain. And nothing that I did seemed to affect that, to mediate it. I obviously took analgesics and, tried to rest as much as I could, but the pain remained. And so by the time I actually arrived in Egypt, I was still in severe pain. Other people carried in the equipment and helped me to set it up. And then leaving only the antiquities inspector and me in the chamber, we began the experiment. So first of all, let me explain what the experiment consists of. Stretching a membrane across the open top of the sarcophagus, placing a small speaker in the bottom of the sarcophagus, just as if I was lying there or someone was lying there making sound, vocal sound, but in this case being made by a speaker, instead of a person. And the speaker was connected to an electronic oscillator so that I could inject pure tones into the speaker, right? Now, also, I think some of your viewers who have actually visited the King's Chamber and seen the sarcophagus will know that its top surface is not level. It's like one side of the sarcophagus is higher than the other. So I obviously knew this in 96 when I had measured it. And therefore, I had taken along all sorts of special items to be able to level the sarcophagus. It also has a broken corner. I had taken along an aluminium corner, specially made to repair temporarily. I had taken along blocks of styrofoam, polystyrene, and gaffer tape, and all sorts of things, to effectively do a temporary repair. Anyway, stretched the membrane across the top of the sarcophagus, weighted around the perimeter with 43 little bags of sand, which we had collected, by the way, outside the pyramid. They've got plenty of sand in pyramid in Egypt. And then basically turned on the oscillator, sprinkled on sand on the surface of the membrane, and then just basically watched for any kind of resonance effect. So the very first image that appeared in the membrane, on the membrane, in the sand, was so astonishing that it just took my breath away, and that of the antiquities inspector who was standing nearby and saw this happen. And it was the Djed pillar of ancient Egyptian iconography. So this, for those of you viewers who don't know what this is, the Djed pillar represents the backbone, the spine of the god Osiris. And it's a very powerful symbol in ancient Egyptian iconography. And here it was manifesting on this membrane, a series of horizontal striations. It was not static, it was dynamic, it was kind of snaking on the membrane. It was an extraordinary, aspect of this experiment to witness. I had not expected anything like this. I thought what I would be witnessing would perhaps a series of geometric patterns that I would later analyze in the lab. to to calculate the resonances in the sarcophagus, the specific frequencies, which we can talk about later in terms of how the geometry relates to specific frequencies and so on in cymatics. But anyway, so this was an amazing moment. The antiquities inspector rushed across to see what I was doing, and he said, "How you do that? How you do that?" And I just had to shrug my shoulders. I didn't expect it, obviously, and it was an amazing moment. So then he wanted to be involved, and he wanted to help. What can I do to help you, and all of this. So basically, we then worked as a team, and he would be, for example, cleaning off the sand off the surface, sprinkling on fresh sand, and while I was operating the controls and so on. And many, many hieroglyphs appeared that day on the surface of that membrane, or what appear to be, let's say, hieroglyphs, and far too many to be coincidental. Clearly, there had to be a mechanism here whereby these hieroglyphs were appearing. But about 20 minutes into this amazing experiment, I suddenly realized that I had no pain in my lower back, all the pain completely gone. And Rene, in that moment, I thought, I know what's happening here. I'm so excited, of course, that my blood will be running with endorphins, all sorts of wonderful hormones will be being secreted by my excitement. And this is what's masking the pain, right? It's just mediating it or masking it. And when I get outside the pyramid, I'm thinking the pain will come back, but the pain never did come back. So not only did it not come back, but I was so strong in my body, I was able to carry out literally help to remove all the equipment from the pyramid. So I realized, two things in that moment. One was that here was a mechanism, a healing mechanism that was unknown to science at that time. And two, the extraordinary results of the cymatics experiment indicated to me that here was a potential new tool for science. Yes, Hans Jenny had investigated this, and so had Ernst Chladni, but really, even though those two acoustics pioneers had investigated cymatics, or in Ernst Chladni's world, it was, it's now been, they're now termed Chladni forms, but still the world of science had not really embraced this science, this new science. And so I believed that because of the success of the cymatics experiment, that there was potentially a powerful new science here that could be started. And so, yeah, it was a really exciting time for me. And then, of course, it was life-changing, because when I returned home, I had an acoustics consultancy business at that time. I immediately began making plans to sell the business and so that I could move into pure research. And that's exactly what happened. So I began my research, pure research, in 1999. 2 years later, I had sold the business and began my research. And here we are all these years later. And you can see my lab behind here. And we have many famous scientists who visit us here. And the work is really very, very fulfilling and exciting, Rene.
Could it be that the quartz, also used in hard drive and computers, has something recorded in it? So that you stimulate that recording, and that could have made the effects, healing and the figures that appeared. What's your take on that?
You mean in relation to the Egyptian experiments?
Yes, exactly. So that it was quartz and granite, or the quartz in the granite in the chamber. So quartz is also used to record electromagnetic signals. So maybe maybe there was something recorded in that stone that you triggered, and that sent a frequency. And
interesting idea. it's certainly not my hypothesis, Rene. I have my own thoughts on this, which I'd be happy to share with you if you wish, because, you know, obviously there has to be a mechanism. As I mentioned, all of these hieroglyphs appearing, you know, yeah, I mean, some people would say, oh, it's all just coincidence, but, you know, in the world of science, yeah, of course coincidence exists, but here we have too many images which resemble, so strongly resemble ancient Egyptian hieroglyphs. Anyway, so my hypothesis in a nutshell begins actually in a town called ancient Nekhen, which was also known to the Greeks as Hierakonpolis. It's a town, it's about, I think it's about 40 kilometers south of Luxor in Upper Egypt. And in this town, around about 3,200 BCE, or round about that date in history, so all, you know, more than 5,000 years ago, in this town is where, according to the Egyptologist, that granite was first being worked in ancient Egypt. So before that, other stones, softer stones like limestone, for example, had been worked. But up at this particular time, 3,200 BCE or thereabouts, granite was first worked in ancient Egypt. Coincidentally, and I don't think it is a coincidence actually, but according to, you know, Egyptology, coincidentally, this is the same town and same time in history when the ancient Egyptian hieroglyphic language was being developed, right? This is the time that the first extant examples of the hieroglyphic language have been found. Some people date them a little bit earlier, even as early as 3,900 BCE, but it seems to be the general mainstream is about 3,200. Anyway, whatever the date, here we've got one town, one place in history where hieroglyphic language and granite are brought together. And my hypothesis is simply this, that in the quarry in Aswan, which was obviously even further south, they would have extracted a block of granite. And then this block of granite would be brought upriver, up the Nile, to this town of Nekhen, where they had a workshop that fashioned the granite into an object that they wanted to use. In this case, a sarcophagus for the King Khufu, where they were building their pyramid, you know, up in Giza. So in this workshop in ancient Nekhen, the men would be fashioning the granite. Now, you have to know that when you strike granite, it does have an amazing resonant ring to it. It is very resonant stone. And the more that you hollow it out, the more it becomes resonant. So if you strike a large block of granite, it will still ring, but obviously with a very, very low frequency or low pitch. If you, as you begin to hollow it out, so the pitch will begin to rise, but it's still a complex sound. It's always complex because of the resonant properties of the quartz crystal, right? Now, one aspect to my hypothesis concerns the effect known as synesthesia, which is a cross-wiring of the senses, where in certain individuals, and even I have it to a limited degree in my own body, one's brain can actually detect energies in a different way. So like, for example, with my hearing, when I'm on the verge of sleep, if there's a sudden noise in the, say, the bedroom, I will actually see that sound in my mind's eye. And the reason this happens is because in your hearing system is actually shut down by your brain when you go into sleep mode. You literally, it shuts down the hearing so that you're not disturbed when you're in a deep sleep. However, there's a kind of in-between level where the hearing is starting to be shut down, and there's a mechanism in your ears, because you have membranes in your ears, like the tectorial membrane, for example, and the basilar membrane. These membranes, of course, as I mentioned earlier, whenever you have a membrane and you have a sound, you have to have a cymatic pattern. Laws of physics, right? These patterns are occurring all of the time on your membranes in your cochlea, but your brain suppresses them. Basically, it's only interested in analyzing the sounds that are coming in, not the pattern that the sounds create. So it suppresses the pattern. But when you're on this, in this verge of just going to sleep, or if you're one of these amazing individuals who have the ability to see sound all of the time, then these patterns that are being created on your tectorial membrane and that then are read by the organ of Corti, all these little cilia, all these little hairs, you know, read the pattern basically. That effect, I'm saying, hypothetically, was experienced by this the vizier, the scribe, who would be standing there beside these guys who were striking the granite with their tools in Necken. He's there to measure, like a quantity surveyor, to measure the work, you know, because the guys who did this work had to be paid. They didn't use money in those days. They were paid in salt and beer and grain and, you know, other aspects of food for their families. And the vizier, his work was to measure that, you know, like a quantity surveyor. So he's standing there and he's experiencing these sounds. And as the sounds are coming towards him, he is literally seeing these patterns in his mind's eye. And remembering that at the same time in history, the Egyptian hieroglyphic language was being developed. So he sees some of these patterns. These are naturally occurring patterns created by sound, by the resonant properties of in this case of granite, imprinted on his membranes in his cochleas. He sees them in his mind's eye and he thinks, wow, these are interesting patterns. I will take a note of these patterns and maybe we'll use them in our hieroglyphic language. Perhaps he thinks they're coming from the gods, you know, who knows what he might have thought. But this is why, you know, thousands of years later, I go into the pyramid, excite that same sarcophagus with sound, and lo and behold, I see the same patterns that he saw. He saw them in his, you know, in his mind's eye. I see them physically on the surface of the membrane. So that's a kind of outline of the hypothesis. Of course, it might not be correct, but you know, that's my current hypothesis.
Yeah, but for me, it's a nice bridge to make a few steps to the building environment. So, as you're saying, so the frequency gives a pattern, actually a specific three-dimensional shape. So, does it also work in the other way around? So, when you have a three-dimensional shape, like a building or a room or space, that there is a certain unique acoustic signature of that space. And could your cymoscope be used to make that visible? So for instance, a lecture hall. What is the specific signature, acoustic signature of a lecture hall, of that specific lecture hall?
Absolutely, that can easily be measured. Of course, acoustically, you can record the sound in a space. And that sound that you're recording, of course, has many aspects to it. The resonant properties of the space will affect the qualities of the sound, but also the distances involved between the various faces, the various boundary conditions within that space will affect the phase shifts. And this is an interesting aspect to sound and the cymatics that I think would be something we could discuss here, because the phase shifts within sound, when they are recorded, they have specific effects when you then make that sound visible. You know, so we're not just talking about the harmonic qualities of the sound, for example, or the reverberation time of the sound. which also they also have effects, of course, when you make them visible, but equally the phase shifts. And one of the aspects to this work that would be worthy of discussion is the holographic, what I call the holographic properties of sound. So sound is I think from a scientific perspective, would probably be viewed as quasi-holographic. You know, some scientists would suggest that it's not fully holographic. But, you know, one of the definitions of holography is if you take a sphere in this case, of sound energy. Of course, all sounds are spherical in their, all audible sounds at any rate, are spherical in their space form. We use this term sound wave, but in reality, there's no such thing as a sound wave in nature. Sound waves don't really exist. What does exist at least in the audible spectrum, are sound bubbles. And these bubbles are, of course, are oscillating in and out with the qualities of the sound itself. And when you graph this oscillation, this periodic oscillation of the sound bubble, that's what we see as a graph. You know, so if we look at for example, on an oscilloscope, here we have an oscilloscope device. If you graph the energy, the XY coordinates, you will see a wave, but the wave does not exist in nature. It's simply, like I say, it's a bubble. Okay, so when that bubble emerges, or we're going back to holography. Sorry, I'm getting carried away here. So one aspect, one definition of holography is that if you look at any point on the surface of this bubble, if you were to be able to zoom in and see, for example, a molecule in the air that's vibrating, it has certain vibrational characteristics relating to the sound itself. And then you were to look at any other molecule in the core of the bubble, you would find exactly the same data. In other words, the same data exists throughout the whole of the bubble. Any one molecule or one atom even within the bubble is carrying all the same data as on the surface of the bubble, as the bubble expands. So that's a simple definition of holography, and indeed that does happen with sound. So all sound in that case you could say is holographic or quasi-holographic. It's containing data. And this aspect of sound is something that allowed me to work with dolphin sounds and to be able to actually image with the cymoscope instrument the same images that the dolphin itself was seeing with sound. You know, dolphins see with sound. They have this ultrasound sense where they send out a beam of high frequency sound, usually something between 150,000 and 200,000 hertz. That high frequency beam of sound is very, very directional. So I mentioned about the spherical nature of sound. Yes, that's true. It is spherical at audible frequencies, but as the frequency rises, so the bubble starts to flatten, and eventually, if you get up to hundreds of thousands of hertz, it becomes like a kind of searchlight beam. It becomes very, very directional, and this is how the dolphin is able to send out a beam of energy. That beam of energy is unmodulated. It has no data in it. It strikes an object, and when it strikes the object and reflects from the object, it's now carrying spatial data relating to the shape of the form of that object. And the dolphin then images those reflections in its cochlea, just as I was describing earlier, membranes in the cochlea, which then show the image, the imprint of that object in the left and right cochlea of the dolphin. And that's how the dolphin is able to literally perceive its world when the waters are dark, when the waters are murky. It can see with sound, right? These are all the holographic principles of sound. And these principles apply even to a concert hall. You know, we think about the experience that we have of an orchestra, for example, in a concert hall as being, something magical, which of course it is. It has a wonderful quality to it. But we're sitting there experiencing it, not realizing that we're actually experiencing holographic sound or quasi-holographic sound. These are such wonderful concepts to consider, Rene. I mean, I feel
I was more taking it a leap into when we do that, certainly for concert halls, but maybe more obvious in a hospital room. There is a core frequency of that room with the patient. If you can add on something, just like in music, you can add on sonic scaffolding. You used a term. I like that term. Maybe the whole room becomes a resonating device, and gives an experience similar to what you had in the King's Chamber. Would that be possible?
Oh yes, absolutely. Of course. But I mean, operating theatres, of course, are typically, they have very hard surfaces so that they can be washable and easily cleaned. They have to be clinically very, very clean. So therefore, they typically have hard surfaces that are therefore resonant. And very often, of course, also in operating theatres, they are made in utility space forms. In other words, they are either square or rectangular. They're not made in odd shapes, are they? So, and when you have a square chamber or a rectangular chamber, the primary modes, the primary resonant frequencies of that chamber will be very dominant at specific frequencies. And of course, it's exactly what you don't want if you're creating a recording studio. You don't want dominant frequencies. Mm-hmm. But in those kind of spaces, I'm talking now back to the operating theatre. I suppose the resonant properties of the chamber are not particularly relevant to the surgeons, doing their work in there. They will notice a reverberance, of course, because of the clean, hard surfaces, but they probably ignore that. But I do know that surgeons very often listen to music in an operating theatre procedure. They will, I'm not talking about headphones. Very often they will have a small music system in there so that they can have gentle music while they're actually carrying out the operation. And no doubt that will have a kind of reverberance to it because of the hard surfaces in that chamber. What the surgeons will not realize, because the science is not really yet published to any large degree, but the idea that every cell in their body and every cell in their patient's body is receiving a cymatic pattern from the sounds in that room, whatever the sounds are, whether they be music, or other sounds that are happening from machinery or whatever. All of those sounds will be creating cymatic patterns on the surface of their cells and on their patient's cells. And this has large implications for healing, as I started out by telling mentioning.
Maybe because you give me a wonderful bridge for my next question, and after that we will come back to healing, if it is okay with you. Because how I look at the environment is, for me, it's the outer environment, consisting of a physical environment, so the building itself, with all the things in and around it. The digital environment nowadays, because we have a digital workplace, many people, but also the social environment, because there's also an interaction between the etheric fields of people and the things going on. So I want to read something and then ask your thoughts about it. As music is frequency of sound, architecture is about visual, geometrical and spatial frequencies, and much more. When we move through a building, it can shape our thoughts and feelings, just as music does. So music can influence our moods. It is as walking through the instrument itself while it is being played, a building. So you could say this is a kind of three-dimensional machine, harmonically tuned, if it is correctly, as a resonating device. So the architecture could act as a pacemaker to stay dynamically and proactive in tuning the heartbeat of the organization or whatever is going on there, or the individuals, literally the health and well-being. So people like Albert Einstein and Max Planck and Nikola Tesla stated that everything is energy and thus frequency. It should therefore be possible, to my opinion, to introduce a vibration that acts like a tuning fork. So creating, so what is the existing frequency and what can you add on to create a tuning fork for whatever's going on in that space. So in the tuning fork that centers then the cacophony of frequency of the built environment, like the electromagnetic smog of modern technology, the etheric fields of the humans that are in that space, and balancing them all into harmony again, just like a music symphony. And because all these frequencies are resonating and amplifying each other, it should be treated in a holistic way. It's not just one thing. What are your thoughts about this sonic scaffolding?
Yeah, well, thank you for that interesting hypothesis. I use this term sonic scaffolding in relation to abiogenesis, which is, you know, how life began on planet Earth. So that's a whole new topic, of course, that we could discuss another time. But in essence, life began, it's generally believed, around hydrothermal vents on the ocean floor, where there are bubbles coming up, or bubbles being formed by gases that are emitted from the core of the Earth, coming into the ocean water, creating these little bubbles. And of course, the sound present, and that's the sound of all of the jostling of the bubbles, creates kind of white noise. And there's something called Helmholtz resonance, which is simply the natural effect of resonance occurs even at the microscopic scale, where specific frequencies are chosen, literally, not in a conscious way, but automatically through the laws of physics, by the volume of gas contained within each bubble. So that volume of gas, whatever size of the bubble is, whether it's microscopic or the size of a melon, you know, there will be a resonant frequency that is primary to that bubble size. And whenever you have sound and you have a membrane, in this case, a microscopic bubble or a large bubble, there will be a cymatic pattern occurring on the surface of that membrane. And that pattern is a way to organize the prebiotic materials that are in the water to begin with, that have been brought to Earth by comets and so on. It's a big subject, you know, we could talk about it another time. But coming back to this term sonic scaffolding, it's occurring all of the time. You know, as I mentioned about the operating theater and how sounds in the operating theater are literally imprinting on our cellular membranes, that's happening all of the time whenever there is sound present. And this is true even of the built environment. You are in an environment of a specific geometric shape or form, and that form actually informs the sounds that will be imprinted onto your cellular membranes. So when an architect designs a specific form of building, he or she, at this stage in science, may not realize what I'm sharing now about, you know, how that shape, that form actually informs the patterns that will literally imprint on the membranes of trillions of cells in our body. Perhaps architecture hasn't quite reached that point yet of understanding, but in future years, I believe that, you know, this new science of cymatics will in fact make a significant impact on architecture and on many other sciences, because it is such a wonderful and exciting new area of study.
That's exactly
so
the
yes.
yeah. That's exactly the direction that I'm pointing at. Not so much in creating new buildings, but how could we improve the source code of the frequency in a specific room of an existing building, just like we improve the acoustics of a existing concert hall for whatever performance is going on there. So is something similar possible for rooms, existing rooms?
I totally agree with you. You know, recently,
but not in the context of health, the health of people. So.
Yes, of course, because again, coming back to the biological aspect of sound, our cellular membranes are covered by what are called integral membrane proteins. These are little, like little antennas that project from the surface of the membranes about all of our cells, all of our body cells, not the brain cells, but all the body cells have these IMPs, integral membrane proteins. And when a cymatic pattern occurs on the surface membrane of the cells, it literally massages the IMPs. Now, this is, you know, one of the many mechanisms by which sound has healing properties, but equally, there are some aspects of sound which are harmful to us. And this is one of the aspects I wanted to just briefly cover with you now, because you're talking about the built environment and how architecture may in future years, you know, consider these aspects. Because if you take, say, take the cymoscope instrument here, and you inject a harmonious sound where the frequencies are all related mathematically to each other by multiples or submultiples, you get a harmonic sound. When you inject that harmonic sound into water, what you see is great beauty. It's symmetrical, it's beautiful, it's organized, and it appears to us subjectively as beautiful, right? If you then alter the sound so that the frequencies are not harmonically related, and this is an example of this would be a machine, you know, like a truck sound, or you know, an engine like a lawnmower engine, or some kind of engine that is not very well balanced. Then you get a discordant sound. It's not pleasant on the ears. When you put that sound into the cymoscope instrument, you see ugliness, you see distortion, you see skewed patterns that are clearly, you know, not visually beautiful. Now, remember what I was talking about there, the cellular membrane. So the cells in our body are receiving those ugly patterns. What does that do? How does the cell, you know, respond to this ugliness at the cellular level? It's a very important question. And it now coming back to the built environment, if the built environment is not harmonious, literally to the eyes, then it's also not harmonious to the sound, because the shapes inform the sound, and that informs the patterns that will be imprinted on our cellular membranes. So the whole thing is interconnected. You know, if we have a beautiful building that, well, subjectively we say if that building is beautiful, or the interior of that building is beautiful, then the sounds that are created in that building, you can guarantee that those sounds will be harmonious, and therefore our cells will receive them as being harmonious. And I think that's very important.
So it is more that an architect should work like a composer. He has different, he has not notes and instruments, but he has building blocks and colors and shapes and angles and what have you more. And the way that he composes could be that architecture creates a symphony of form. Architecture is a symphony of form, so not this frozen music. In my opinion, it's a symphony of form. And you can reshape it, so that's my idea. So when you measure the existing frequency and what it does on a human body, maybe by adding a color or taking something away or making the composition different, you can create a more healthier environment for people that are in that space.
Very well put, Rene. Very well put. Yeah,
and
it's an exciting new aspect of science, but also now potentially for the future, an exciting new aspect of architecture.
Exactly, and who knows? Maybe when you go to take the example for universities, maybe we can create a frequency that people get curious to figure something out, or that they get more harmonious in discussion or working together, cooperation. So I think when music can do that, and we know that there are several experiments with music to create certain moods in people, or with colors. There's a lot of research done in that field. But when you all combine it, and that is actually what architecture is, it comes all together. But it is not, most of the time, not made with a holistic plan. It is just, put some together, and it can also work in the different direction then. But this is, again, a nice bridge to our last question about sound frequency, source of life energy. You touched already briefly, and healing. Maybe we can focus now more on the healing aspect. So, actually we said already that according to new science, we humans are not a physical entity, but energy waves of interacting frequency that can affect the condition of our body. So, our waves, the human waves, get entangled and resonate with those of the physical and digital environment and the people in it. So it is a complete cocktail of frequency. And just when you mix a lot of drinks, it does not mean that the result is drinkable, although maybe the parts are, but not the composition. The same goes with human thoughts and emotions. That actually is also frequency. It can be measured in a way. And maybe that's a nice point to that you tell something about the last experiment in April on the first field about live blood and what happened there. I was present, so I know, but maybe you can explain it to the audience.
I'd be happy to. Yeah. So I mentioned much earlier in our discussion here that I've been on this journey of exploration in terms of understanding how my lower back was healed all those years ago in the Great Pyramid. And now, after more than 2 decades of work, I think I have a fairly clear picture of the biological mechanisms at work. One of the many, so I'm not going to go into that now, but one of the many ways that I've been approaching this subject of healing in relation to sound and music is to use human blood. It's fairly simple to obtain quantities of human blood from a blood bank, for scientific purposes, and of course the experiments that I conducted are fairly simplistic, but importantly so, because if you remove as many variables as possible, then what you're left with, is clear evidence. And in this case, the way the experiment works is really simple. You take a vial of human blood and then decant that into 2 smaller vials. One vial we place in an incubator in our Faraday cage, which is an electromagnetically screened cage. It's a small room in which we have the incubator. It's also, by the way, very, very quiet. It's acoustically lined. So the sound level in there is typically kind of 25 dBA, so very, very quiet, not quite as quiet as an anechoic chamber, but not far away from that. And then the other vial we place in the lab here, in the main body of the lab, and goes into another incubator where there's a small speaker. So now we can play music to that blood, okay? So let me just begin by saying that if you take a vial of blood and you count the number of blood cells that are living in that vial, and then you look at the number that are dead, and then you look at the number that are old, you will always find a kind of roughly 1/3 to 1/3 to 1/3. So there'll be approximately 1/3 of the cells in the blood will be living, and then usually about the same ratio will be number will be dead already, and then about the same again will be classed as old. What does old mean? Well, in medical terms, it means that the outer membrane of the cell is starting to break up. It's losing its integrity, and pretty soon, you know, it will be dead. The body will be replacing it, of course, ultimately. But in a test tube in the vitro environment, you have this ratio of cells that are living and old and dead. So what I was interested to know is, will music in any way affect this ratio of cells that are old versus those that are living? And indeed, that's exactly what we found. There are many experiments. So we've had Professor Sung-Chul Ji from Rutgers University here working in the lab. He helped to design the original protocol, and we did the original experiments, which were based on classical music versus kind of general pop music. And the first results that we obtained were pretty astonishing, in that, first of all, we discovered that in every case, every type of music that we used, every genre of music, produced far more viable red blood cells after immersion in music than from the quiet Faraday cage control environment. And what this meant was that somehow a process was occurring within 20 minutes, by the way, because that's the length of the experiment time. Within 20 minutes, the membranes of the old red blood cells were being repaired, rejuvenated, and then therefore counted by the automatic cell counter as living. So before, you know, from the control blood, they would be, the old cells will be counted as dead, even though they're not actually dead, but they are counted as dead by the cell counter. Only the viable red blood cells, only the healthy red blood cells are counted as living. But now, after music, even the old red blood cells are counted as living. So there's been a repair to their outer membranes within 20 minutes as a consequence of immersion in music. And that was an extraordinary result. But equally extraordinary in a way was we discovered that classical music is not as efficacious as popular music. You know, it's kind of counterintuitive. You would think that I thought that classical music would actually be appreciated, let's say, by the cells more than the popular music. But it's not about appreciation in this case. You know, it's not an intellectual aspect of music for the cells. It's about the frequencies in the cells that actually generate the healing process. So in essence, because we don't have much time now, but in essence, the low frequencies in the music are driving this repair mechanism for reasons that, you know, I don't have time right now to go into, but the low frequencies are predominantly driving the repair mechanism. But now referring to this latest experiment that we conducted online with thousands of people, sending not only sending their loving intentions, but also they were creating a virtual choir. You know how so many Zoom meetings these days, you know, creating virtual choirs. So in this case, the blood in the Faraday cage, of course, was just very, very quiet environment, but the blood in the incubator in the main body of the lab here was receiving the virtual choir and the intention of all these thousands of people for healing intention being sent to the blood. And of course, they were sending their healing intention to the blood in the Faraday cage. But before the experiment, well, you know this because you watched it, before the experiment, I kind of prophesied what I believed would happen, which was that I believed that the blood in the Faraday cage would have show very poor viability versus the blood in the main body of the lab here. Because why? I believed that intention, this power of intention that any human has, could not pass through the electromagnetic screening of the Faraday cage, right? And I was proven completely wrong. Completely wrong. I mean, the result was extraordinary. As you know, the blood in the laboratory from the laboratory incubator had a huge, and had so many red blood cells that were viable that the cell counter could not even count them. And then, you know, I had to test the blood from the Faraday cage, and my God, you know, we found the same result. There weren't quite as many as viable red blood cells. You can see from the screen of the cell counter that they're not quite as dense from that Faraday cage, but so many, again, that the cell counter could not count them. So what does this mean? Well, it means, in a nutshell, that the power of intention that all humans have is not an electromagnetic phenomena. Whatever it is, it's not electromagnetic, because the Faraday cage is screened electromagnetically. You know, you can take a mobile phone in there or any kind of device, or radio or TV, you will not get a signal. You know, that's the essence of it. No electromagnetism can pass through that cage. But here, the intention of thousands of people during this experiment went straight through that cage, affected the blood, and the cell counter showed the result, and it was an extraordinary result. So it has changed my view completely, you know, of intention. Of course, now I'm left puzzling, well, what form of energy is it, Rene? I don't know.
Yeah, and exactly, because there was, when I remember well, there was no music in the Faraday cage, isn't it?
No, that's very, yeah, it's 25 dBA, very, very quiet environment.
So
no music.
Yeah, yeah. So the music was only played to the sample in the lab and not in the cage, although the result was almost similar. So it was
very similar.
So that intention is as powerful, you could say, as those
almost as powerful as the music. And given the fact, of course, also remembering that these thousands of people are all over the world. I mean, they're not just, you know, in the UK where I am. They're, you know, and some of them are in Hawaii, some of them are in Australia, you know, they're all over the planet, basically, and sending their intention, and that's the result. So it was extraordinary, and it has shaped my views, of course, a lot. And, you know, as a scientist, I have to now accept this result. I have to somehow work with it to shape, you know, how my future experiments will be conducted and so on. So yeah, it's a wonderful privilege, you know, to be working in this field, Rene. And it's been a great pleasure chatting with you today.
Yeah. So actually, we have a full loop with Einstein. We ended at this spooky result in the distance.
Spooky action at a distance.
Yeah, the spooky action at a distance. Yeah, that's the term. Yeah.
That's it, yeah. Wonderful.
And we touched so many things, that also the first quote we started with, the more you know, the more you realize you don't know, that there are so many more things we could discuss. And hopefully you would give me another interview that we can zoom in more specific in one or two topics.
Yes, that would be a great pleasure. I know that we, you know, covered so many different topics in kind of a broad brush way. But hopefully, you know, your listeners will have found it, or viewers found it interesting and a little bit inspirational, I hope. But anyway, it's been a great pleasure for me, and it's been wonderful chatting with you today, Rene.
Thank you very much for your time and for your sharing.
It's a pleasure. Bye-bye for now.
Bye.